So we are looking at interconnection. Interconnection means there is one network जिसका आउटपुट जो है वो दूसरे नेटवर्क का इनपुट बनता है. So what you're looking at out here is called as a cascade network. And whenever it is cascade, then only you can find what is called ABCD parameters. So when I say determine the ABCD parameters for this interconnection, we are going for cascade. So cascade is like multiplication. So the output of one network is getting into the input of the other network. And hence we have to find what is ABCD parameters. So the question will be find ABCD parameters for this interconnection. So our first job is to find where are the two networks, where should I cut it? So now let us see how to consider the two networks. I have already taught you that there are two types of network, T and pi. So now when you look at this particular network, can you see a T and can you see a pi? So you can clearly see a T. Can you see a T? Anyone can suggest that which of these is for like forming the T network? So if you look at the T network, you can see that the 2 ohms, the 2 Henry and the 2 Farad. That means I'm going to cut it over here. Can you see this? You can see a T shape here. And rest of it you can see as a pi network. So that means there are two networks. That's how you identify it. Because how will I know how to cut, where to cut? So therefore, this 2 ohms, this 2 Henry and 2 Farad is going to form one network. And I can have the other as the pi network. So now this network, I'm going to take it as N1 and I'm going to take this network as N2. Now suppose I'm going to take this N1. So I'm going to take this as the resistor. This is my capacitor and this capacitor is nothing but 1 upon 2s. And this is my inductor, which is nothing but 2s. And this is nothing but 2 ohms. And this is how the network will look like. So you will have plus minus, you will have your V1, you will have your I1, you will have plus minus, this will be your V2, this will be your I2, right? Now you have to find out what is the current over here, that is I1 current, and you will solve for this current, I2 current, right? So now you're doing your normal mesh analysis and you find out the equations in, now this is ABCD parameters. So you have to get it in terms of V1 and I1, if you remember. So let us start with a normal KVL. So it will be V1 minus 2 times of I1 minus 1 upon 2s times of I1 plus I2 is equal to 0. And the next one will be nothing but V2 minus 2s times of I2 minus 1 upon 2s times of I1 plus I2 is equal to 0. So I want you to solve these equations and get it in terms of V1 equal to and V2 equal to. Quickly do it first. Get me V1 equal to something and V2 equal to something. It's not going to be difficult. Get it in terms of I1 and I2. Get it in terms of I1 and I2. Are you able to do it? Please solve it in terms of I1 and I2. And so you should get something like 2 plus 1 upon 2s times of I1 plus 1 upon 2s times of I2. Could you confirm if you get it? You can unmute yourself. I have given you the permission. So I hope you have been able to get this. And the next V2, I hope you're getting something like I1 upon 2s plus 2s plus 1 upon 2s times of I2. So I hope you're getting these two. Are you getting this? Now, what I want you to do is I want you to rearrange the first equation, that is this one. Okay, anybody, one of you all could tell me the standard equation of ABCD parameters? Anyone could unmute and tell me? What are the standard equations of the ABCD parameters? What should we get it in
V1
terms?
is equal to AV2 minus BI2.
Yeah, V1 is equal to AV2 minus BI2, and the second one would be?
I1 is equal to CV2 minus DI2.
Correct. So now if you look at the second equation, that means we want V1 and I1 on the left hand side, and we want V2 and I2 on the right hand side. So which equation already has three of it? Which equation has either V1, V2 and I2 or I1, V2 and I2? One of these equation has it. So I mean, you just have to rearrange that equation. Which equation? Is the first one or the second one?
Second.
Yeah, the second one already has it. The second equation already has V2, I1 and I2. So you just have to rearrange it. So please rearrange and tell me what you're getting. So I1 upon 2s on one side. The other side will go as V2 minus of this entire thing. So if you solve that, I think you will get 4s square plus 1 upon 2s times of I2. So when you place this, you should get I1 is equal to 2s times of V2 minus 4s square plus 1 times of I2. So just check whether you're getting this equation, because this equation essentially represents that second equation of yours. So this is your first equation, this is your second equation, and what you have done is just rearrange the second equation. You got the third equation. So can you tell me which parameter have you obtained? Is it A, B, C, or D? Which one have you got? Yes, you have got प्रगति C and D. ये C है आपका और ये आपका D है. नेगेटिव साइन नहीं लेना है क्योंकि इक्वेशन में ऑलरेडी नेगेटिव साइन है. तो you've got your C and you've got your D. Now how to find A and B? What should I do? Because now I've got the second one. That means I got this I1 in terms of V2 and I2. How do I get the first one? What should I do? Anyone?
I will substitute I1 in the first equation.
Yes, I have to substitute my 3 and 1. Please substitute 3 and 1. So when you substitute, you should get V1 is equal to 2 plus 1 upon 2s times of, now that I1 has to be substituted, that is 2s V2 minus 4s square plus 1 times of I2. This has to be substituted, plus 1 upon 2s times of I2. So substituting, we will get V1 equal to something. So please check this times V2 minus this much times of I2 and tell me what you are getting, because that essentially will give us the matrix which we will write as A1, B1, C1 and D1. So I have already got C and D. So I'm just writing C and D, which I have already got. Please tell me what is A1 and B1 after solving it. Please solve this part.
Ma'am, A1 is 4s plus 1,
Yeah, A1 is 4s plus 1.
B1 is 4s square by 2s, or 4s by 2.
Just check that because it's a bigger equation, no, with I2. Here it is correct, 4s plus 1. But here it's going to be a little bigger equation. Are you getting this answer? 8s square plus 2s plus 2. So this should be your A1, B1, C1 and D1. Okay. So once you get A1, B1, C1 and D1, then what we are doing is we are taking the other part of the circuit. So what we did first is we took the T network, right? We took the T part of it. Now we're taking the pi part of it. So the pi network is a very small one. So you will see that the network is, this is going to be 1 by S. Now, if you look at this, this is going to be parallel. So that means you will get a network, you can do it like this also, or you can just solve this. This will become 1 upon S plus 1. This is as good as taking 1 upon S into 1 upon 1 upon S plus 1. So you will get this as 1 upon S times of S plus 1 upon S. This will get cancelled, and that's how you're getting this. So we got this. Now we are applying mesh analysis on it. So this is again your plus minus V1, and this is plus minus V2. You can put it as dash also, but I normally want to avoid the confusion. So here it will become V1 you're going to get something like this, right? Because this will become V1 minus 1 upon S plus 1 I1 plus I2. So this is the kind of equations you will get. Now, once again, we are looking at two equations. And the question to use the same, can we rearrange something, right? So from equation number 2, we can rearrange it. So I1 upon S plus 1 is equal to V2 minus 1 upon S plus 1 times of I2. So I1 is going to be nothing but S plus 1 times of V2 minus I2. So again, you've got a C and you've got a D. Again, this is like your equation number 3. So I'm just going to call this as 4, calling this as 5. So this will be 6. Again, put 6 in 4. And when you put 6 in 4, we will get something. Tell me how much you're getting then. Put 6 in 4. Are you getting something? Yes, you should get V1 is equal to V2. So once you put V1 is equal to V2, so once you get V1 is equal to V2, this becomes our equation number 7. So what we are getting here is nothing but one of these terms is 0. So which one is 0? A is 0 or B is 0? When you're getting V1 is equal to V2, which term has become 0? A or B? Yes, B has become 0 because A is 1 here and B has become 0 here. So now what I'm going to do is I have one more ABCD parameter, that means. So I have A2, B2, C2 and D2. That means I have 1, 0, S plus 1 and 1. And that means I can obviously find the cascade. So the cascade, the final answer is going to be A1, B1, C1, D1, what you got in the first case. Cascade is what? Multiplication to A2, B2, C2, and D2. So this is what you're supposed to do in interconnection. Whenever you have ABCD parameters, you have to multiply both of the matrices. So I hope matrix multiplication you know. So we will write down the matrix of both and then we are going to multiply them. So in the first case, you had got 4s plus 1, you had 2s here, you had 4s square plus 1 here, and you had a big term here that is 8s square plus 2s plus 2. And in the other side, you had 1, 0, s plus 1, and you had 1. So you have to take one quantity multiplied by this, take the second quantity multiplied by this, right? I think you know that already. So this is going to be your 2 into 2 matrix, and this is also your 2 into 2 matrix. And therefore, what we are getting here essentially should be a very big term. right? So it's going to be 4s plus 1 into 1 plus 8s square plus 2s plus 2 into s plus 1. So you should get like 8s cube plus 10s square plus 8s plus 3. You can check this answer. And this one is going to be this into 0 plus this will remain 8s square. ये पूरा का पूरा term यहाँ आएगा, right? So the term of 8s square plus वो same term यहाँ पर आएगा. This will become 2s into 1, 2s into 1 plus 4s square into s plus 1. So that's going to give you something like 4s cube plus 4s square plus 3s plus 1. And over here, we are going to get 2s into 0 and 4s square plus 1. So here you'll get 4s square plus 1. So in this way, you're going to get four parts. That means the final ABCD parameter is nothing but the multiplication of two matrices. So your first job in this particular thing is to identify the circuit from the bigger circuit. So that's why it is called the interconnection of two-port network. So in the interconnection of two-port network, you have two networks. One is the T network and one is the pi network. We are finding the ABCD parameters of the T network, and we are finding the ABCD parameters of the pi network, multiplying them together. So if there is any doubt, please clarify right now. Do you have any doubt in this or in the previous case? So
Ma'am,
in the first, yes, Atharva.
can you show the diagram, the initial question diagram?
Yeah,
I would.
this is the initial question diagram.
Here, ma'am, why didn't we split I2? Like when we combined 1 farad and 1 ohm, then yeah, there should be an I3, right?
There is
Because
no I3, Atharva. There is only I1 and I2.
current will split at 2H and 1
What we
farad.
are doing is this is interconnection of two-port network. You can do this by KCL also.
Okay.
But normally, when we are doing Z and we are doing ABCD and we are doing hybrid, we stick to doing mesh analysis. And only in the case of Y parameters, we stick to KCL because we want I1 and I2 on the left hand side and we want V1 and V2 on the right hand side, right? So if you look at this particular network, it's a clear indication. If you see my circuit over here on the left hand side, I
Hmm.
have a T network, and on the right hand side, it's a clear pi network. So why complicate it? Because initially we used to not identify T and pi for students. So people used to cut it anywhere. But it's not that you can't solve it. You can solve it, but it becomes a little more complicated. Like people used to cut it here because this also is a T,
Yes, ma'am.
right? So you can take it, the circuit becomes a little bigger, only that much. But this is easier to identify because the moment you see a T and you see a pi, then it is easier to solve. Otherwise, your first network will become too complicated for you to solve. It will just get bigger, right? So
Yes.
it is not that you can't solve it like that. You can solve it like that also. But then as time went, as we went taking methods, we discovered that this T and pi is much more efficient for students to discover T and pi. So that's why we decided it's not that you can't use KCL because electrical networks is a very open kind of subject. You can use any method, but you should not get confused in the middle because of the complexity of the equations you're getting in S domain.
Okay, ma'am.
Okay. Yeah. So that's what it is. Now, the next kind of network. So this is one network which is called cascade network. So in cascading, please remember, we take two networks, we find the ABCD parameters of those networks, and we multiply it. That's why this is called cascade connection, and cascade connection depends on ABCD parameters. Now, the second kind of network that we are going to deal here is called the Y parameters. So I want you to write Y parameters. So if I ask you to do Y parameters ka interconnection, so the question will be asking same, that find the Y parameters, but they will indicate that you have to find the interconnection. So now I say interconnection. So I'm drawing the network for you to identify what kind of network we are talking about. So let's take a very simple network first. Suppose it is this one. I'm drawing the network. You can also draw the network. So again, now this is y parameters. So y parameters में क्या होता है कि this connection is not cascade. Cascade is very simple. Do you remember what I told you about cascade? Cascade means एक network का output दूसरे network के input को connect हो रहा है. That is cascade kind of network. While when we are looking at this network, what you are seeing right in front of you is not a cascade network, because they are not a series kind of it's not like a ladder arrangement. I hope you remember ladder arrangement. तो जब भी हम लोग ladder arrangement करते हैं वो एक ही किसी there is no resistor on top, below, or any kind of connection like that. So what is a parallel connection? If you have two networks, so N1 and N2 are two networks. This is the ports of both the networks. This is the port of both the networks. Now, if I take one network का यहाँ से लेके, if I connect it to this one, and I take this network and connect it to this one. So I take the output of this one and connect it to the output of this and connect this, this is called parallel. So this is what connection is on in front of you in this circuit actually. इसका one इसके one को जाता है. इसका टू इसके टू को जाता है. इसका जो वन आउटपुट वाला वन रहेगा, लेट्स कॉल इट एज वन डैश, इसके वन डैश को जाता है, और टू डैश इसके टू डैश को जाता है. दिस इज कॉल्ड एज what we called as the parallel arrangement or the parallel connection. So now whatever you are seeing in front of you is a similar parallel connection. Now whenever I say y parameters, we can understand that we are not going to multiply here, we are going to add here. So let us take the two networks. Can you see the two networks? Which two networks can you see? When you look at this, what kind of two networks do you see? Can you identify the two networks? Yes. I hope you can see the T network. Are you able to see the T network? Yes, the three resistors that you can see here form what is called as the T network. So we are going to take that as network one. So I'm going to draw it separately out here. As it is only resistors, we can be, it's a relief, because if it is capacitor or inductor, again, we have to convert it. So this is plus minus V1. This is nothing but I1. This is your 2 ohms. This is your 2 ohms. And this is your 2 ohms. This is plus minus V2. And this is nothing but your I2. So now what we are going to do is, this is which parameter now? This is nothing but your y parameters, and when it is y parameters, we do KCL. So if it is KCL, then I take this node as my third node, right? So what am I supposed to write? I'm going to write it as I1 plus I2 is equal to V3 upon 2. I hope you agree with me. I1 यहाँ से आ रहा है, I2 यहाँ से आ रहा है, और outgoing यहाँ से होगा. So I1 plus I2 is equal to V3 by 2. Right now, what is I1? I1 is nothing but V1 minus V3 upon 2. And what is I2? I2 is nothing but V2 minus V3 upon 2. Now, what I want you to do is substitute. So I've got one equation here. I've got the second equation here. I've got the third equation here. I want you to substitute 2 and 3 in 1. Everyone, please substitute 2 and 3 in 1 and get me an equation V3 equal to, because I want to eliminate V3. I do not want V3 in both equations 2 and 3. So get me something V3 equal to which I can resubstitute in 2 and 3 to get my Y parameters. So Somebody has to give me that answer. Give me that answer for V3. Okay, so Atharv is giving, Advait is given me an answer and Pragati is given me an answer. V3 is V1 upon 3 plus V2 upon 3. So I hope everyone got this. Now this equation, which I can call as 4, you substitute in 2 and 3. Okay, now when you substitute this in 2 and 3, you will get I1 and I2 ke do equations. So please substitute equation number 4 in 1 and in 2 and 3. So substitute this in 2 and also substitute this in 3. Okay, so I can see Advait's answer. So I hope you have got I1 and I2. So what is I1 and what is I2 that you're getting? I hope you're getting I1 as something like V1 by 3 minus V2 by 6. And similarly, I2 as V1 by 6 plus V2 by 3. Something like this, you will get the answer. So I hope you are getting this answer. You know, so if you get this particular answer, then it is correct, right? So now what we are going to do is we are going to arrange it as y11, y12, y21 and y22. So इस तरीके से हम इसको अरेंज करेंगे तो हमें क्या मिल रहा है 1/3 minus 1/6. I think this is negative, right? So minus 1/6 and 1/3. So I hope you're getting this answer. All of you are getting this answer. So this is your first network का output. सबको मिल रहा है? ये मिल रहा है कि नहीं मिल रहा है? Okay, thank you, Mir. So another network that you have is the second network, which if I go back, I just have one single resistor, वो जो ऊपर वाला था, you know, जो ऊपर का जो 3 ohms था वही है. So this is the only part of the network that you have to consider. So it will become plus minus V1 plus minus V2. You know, the simpler the network, the more confusing it looks like, but it is not that confusing. So you have to do exactly like you have been doing before, you know. So what will happen out here? I can say that I1, I can say is minus I2, because they are exactly opposite of each other. And if I say so, I can also say that I1 is V1 minus of V2 divided by 3. Yeah, correct. I can write this. That means I can write this as V1 by 3 minus of V2 by 3. So इस तरीके से हमें मिल गया है. You don't have to do anything now. You've already got it in that particular form. So what's your y11? I can put it as dash, because you know now you've got two answers, 2 1 dash and y22 dash. If that is the case, in the second case, I can say one is 1 by 3, the other is minus 1 by 3. And हमने क्या कहा है कि ये इसका exact opposite है. So ये minus 1 by 3 और ये plus 1 by 3. So in this case, you have got two y parameters. Now, in the connection which is called as parallel connection, तो y parameters usually parallel के लिए होता है. मतलब आपको कुछ सोचना नहीं है यहाँ पे. आपको ऑलरेडी बताया गया है कि कैस्केड कनेक्शन मतलब एबीसीडी यूज करना है, और पैरेलल कनेक्शन में y पैरामीटर. सो द मोमेंट दे टेल यू दैट यू नो सम नेटवर्क लुक्स लाइक one network is sitting on top of the other network, समझ जाने का कि वो y पैरामीटर वाला है. सो द रिजल्टेंट जो आपका y11, y12, y21 और y22 जो फाइनल आंसर रहेगा, वो इन दोनों का addition रहेगा. So let me just call this as dash and let me call this as double dash so that you don't get confused. And then I have to just add these two. So what will be your answer? 1 by 3 plus 1 by 3. So that's going to be how much? That's going to be 2 by 3, right? Then minus 1 by 6 and minus 1 by 6 is going to, minus 1 by 3 is going to give you minus half. Minus 1 by 6 and minus 1 by 3 is going to give you minus half. And then 1 by 3 plus 1 by 3 is again going to give you 2 by 3. So anybody who could tell me, is this a reciprocal or a symmetrical network? When you look at the final answer, is it a reciprocal or a symmetrical network? What kind of network is this? Is it reciprocal or is it symmetrical? So Gupta is telling me it is both. Nitin is telling me it is both. So is it both? So what is the condition? If you remember, it is y11 is equal to y22 and it is y12 is equal to y21. So if you just equate both of it together, that means this is both reciprocal as well as it is symmetrical network. So I hope this is understood. Any doubts here? Anyone who has any doubts in y parameters? Any doubts? Can I move forward? So I'm doing y parameters only, but with a different network. So let's look at the kind of network. So these are very standard networks. That's why no other notes is required. You know, that's what I keep insisting, because these are like, you know, see, now I've been teaching the subject for over 12 years. So each time we had our books changed, we had our circuits changed. So these are like, I could say the finished product that you're seeing right now. So we never had these networks couple of years back for our students. And so these are already designed specifically for examination. So you will see these common networks in the exam also. So this is the kind of network you have to draw. So you see the beauty of this network. So the beauty of this network is going to be really beautiful, like a Christmas tree. You will see, it looks like I don't know what it looks like, but for me, it's like a tree. So this is 2 ohms, this is 0.5 ohms, this is 0.5 ohms, this is 1 ohm, the 2 ohms, and 0.5. So one relief is always that if capacitors and inductors, this is 0.5, okay? So 0.5 ohms. And this is your plus minus V1. This current is I1. This is plus minus V2. And your current is nothing but I2, right? So now I have got two networks in front of me. Again, I want to split the network. Can you see two networks in front of you? Are you able to see two networks in front of you? That's my first question. Are you able to identify two networks? Can anybody tell me whether you can see the two networks clearly? एक के सर के ऊपर दूसरा बैठा हुआ है. Yes, you can clearly see a pi network which is sitting on top of the T network. There is a pi network which is sitting on top of the T network. So आपको यहाँ एक pi network दिख रहा है, right? It is clearly sitting on this T network. I hope you're getting it. So now your job is to split both the networks. So our first network, which is going to consist of the resistor of 2 ohms, this is going to be 1 ohm, this is going to be 0.5 ohms, and this is going to be your V1, this is your I1, this is your 1 ohm, this is your 2 ohm, this is your 0.5 ohms, this is your plus minus, this is V2, and this is nothing but I2. So this is one network. Now you're going to do your normal KCL on it. And if you look at this network, there is no new node because this itself is your V1 and this itself is your V2 because there is no component here, there is no component here. If there was a component, then we would have to consider it as a new node altogether. So now you will start your normal KCL and your normal KCL is going to be I1 is equal to V1 upon 2 plus V1 minus V2 upon 2. And that gives rise to I1 is equal to 3 by 2 times of V1 minus half of V2. That means there is no complication here because you don't have a new node. So directly whatever you're getting is your Y parameters. And I2 is equal to V2 upon 0.5 KCL ho raha hai plus V2 minus V1 upon 2, and that essentially gives you V1 upon 2, I think in the negative, and plus 5 by 2 times of V2. So what have you got? You got your direct Y parameters. मतलब आपको ज्यादा सोचना नहीं पड़ा यहाँ पर. This is dash, this is 1 2 dash, this is 2 1 dash, and this is 2 2 dash. So once you get this is going to be nothing but 3 by 2 minus half, this is going to be minus half, and this is going to be 5 by 2. So this is one equation which is already ready for you. So please take it down quickly. So this is the solution for the first network. Please tell me when it is done. Okay, so you've completed. So this is the first network. Now you look at the next network. So what we have solved is the pi network. We have the T network with us. So the T network will have V3. Okay. So remember, T always has a 3 because that central node is going to be considered as a new node. So I'm going to go to the T network that I have. That is my second network, which is 0.5, which is 2, and which is another 0.5. So I have a 0.5 ohm with a 0.5 ohm and with a 2 ohm. So this is nothing but my plus minus V1, and this is nothing but my plus minus V2, right? And this is nothing but my third node. So this is my third node. So now what I'm going to do here is I'm going to find out again my parameters, right? So let's find the parameters for this. So what will I write? I will write it as यहाँ से क्या आ रहा है, I1 आ रहा है, यहाँ से क्या आ रहा है, I2 आ रहा है, और यहाँ क्या जाएगा, अपना I3 जाएगा. So I1 plus I2 is nothing but equal to V3 upon 2. And what is I1? I1 is V1 minus V3 upon 0.5 plus what is I2? It is V2 minus V3 upon 0.5. 0.5 is equal to V3 by 2. Now your job again is to find V3 equal to something. So please find V3 equal to. V1 upon 1. Where? Advait, could you unmute yourself and tell me?
Ma'am, in I1 equation, first equation.
Where is 1?
Ma'am, can you just go to the previous slide?
Acha, it's in the previous. Yeah.
Yes. Ma'am, in the this right hand side first V1, it should be V1 by 1, right? KVL.
KVL.
Sorry, ma'am, KCL, my bad. The I1, the V1 KCL equation, it should be
Oh yeah,
V1
yeah,
by
yeah,
1
yeah, 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 yeah,
plus V1 minus.
yeah, yeah. Over here, right?
Yes, ma'am.
Yeah, yeah, yeah. That's correct. The answer is however correct. Okay, there is no change in the answer. Give me V3 equal to. Please give me V3 equal to. what will be V3 equal to? Yeah, so Pragati has some answers. Pragati is saying it will be 4 by 9 V1 plus V2. So it will be 4 by 9 V1 plus V2. So I hope you're getting this answer. Now, once you got this answer V3, you have to substitute that in I1 and I2 equal to. So what was your I1 equal to? Your I1 is nothing but V1 minus V3 upon 0.5. So you have to substitute this. So V1 upon 0.5 minus V3 upon 0.5. तो आपको क्या करना है, ये V3 उठा के इसमें सब्सटीट्यूट करना है यहाँ पे. Similarly, I2 is equal to V2 upon 0.5 minus V3 upon 0.5. So you have to substitute V3 here. Can you do that? And tell me what you're getting I1 and I2. Have you got it? If you have substituted V3, then you should get your I1 as something like 10 by 9 V1 minus 8 by 9 V2. And you should get your I2 as 8 minus 8 by 9 of V1 plus 10 by 9 of V2. So once you've got these two equations, you've got your y parameters. And these y parameters are nothing but y11, I'll say double dash, y12 double dash, y13 double dash, and y14 double dash. And this becomes equal to 10 by 9 minus 8 by 9 minus 8 by 9 and 10 by 9. So this is what you're getting. And as I told you previously, when you want to find the final answer, you have to add them. So in the examination, please remember that when it is Y parameters and it is cascade network, they are expecting you to add both the Y parameters. If it is ABCD parameters, it is cascading. That means you have to multiply both the parameters. So what we're getting essentially out here is nothing but the addition of both of them. So this is going to completely come here. And what was your first part? Your first part is nothing but 3 by 2 here, minus half here, minus half here, and this is 5 by 2 here. So when you add both of it, your final answer, please tell me what is your final answer. Add both of them. Tell me what is your final answer. Okay, so Pragati is giving me an answer. She says it's 47 by 18 minus 25 by 18 minus 25. So 47 by 18 minus 25 by 18 minus 25 by 18, and it is 65 by 18. So if you see this kind of network, what is it? Reciprocal or is it symmetrical? Yes, it is a reciprocal network. What kind of network is it? It's a reciprocal network. So I hope this part is clear to you. This is nothing but the Y parameters. So Y parameters are all about the addition. So now let's look at this was parallel. So then there is series connection also. So every circuit is decided upon one parameter. So if it is cascade, then it is nothing but parallel connection. If it is series, it is Z parameters that you have to use. Sorry, if it is cascade, you have to use ABCD parameters. If it's parallel, you have to use Y parameters. If it is series, you have to use Z parameters. And sometimes the question comes, they will give you just one network and tell you that there are two identical sections are connected in series. So you are supposed to understand, like say for example, a question is asked, an MCQ question or whatever they want to frame. They will just put one network. So let's say I have just put one network, and I will tell you that two such sections are connected in series. So suppose you can take down this diagram. This is 1 ohm, this is 2 ohms. This is plus minus V1. This is I1. This is plus minus V2. This is I2. Right? So they will just tell you that there are two identical sections of the network. मतलब यही दो part है. So एक ही बार solve करना है, and then they will tell you that find out the overall Z parameters of this network. That means this connection has gone in series. So whenever you see Z parameters, you should understand it is series connection. तो series connection में कैसा होता है कि दो network होता है, उसका जो second port रहता है, उसको यहाँ connect करते हैं, एक port ऐसे का ऐसे. It will look like this. This is called as series connection. So if you're looking at the breadboard kind of a scenario, you have two networks and this is called as the series connection. Parallel में हम दोनों connect करते थे. So they will say that there are two identical sections of the network. का मतलब है इसका ही दो बार लेना है, इसको ही दो बार लेना है. and they are connected in series करके question लिखा रहेगा. Two identical sections of the network are connected in series. तो ये आपको समझ जाना चाहिए कि इसी का दो हिस्सा ही होने वाला है. So how we going to do this is Z parameter. So it is very simple. We are going to do our normal mesh analysis here, and we don't have to worry at all. We don't have a third this thing here. So V1 minus 2 times of I1 minus 1 times of I1 plus I2 is equal to 0 will be our one equation. So our V1 is going to come as 3I1 plus I2. Right, the second part of our equation will be V2 minus 2 times of I2 minus 1 times of I1 plus I2 is equal to 0, and therefore we will get this as V2 is equal to I1 plus 3 times of I2. So in this way we are getting our equation directly here. मतलब हमें अपना Z पैरामीटर इधर ही मिल गया है. अभी जो हमें Z parameters मिला है, and what they said that there are two identical sections which are connected in series. मतलब network N1 भी यही है, network N2 भी यही है. इसका मतलब है कि हमें जो final Z parameter निकालना पड़ेगा, Z21 and Z22, which is going to be the addition again of Z11 dash, Z12 dash, Z21 dash, Z22 dash plus double dash, so Z11 double dash, Z12 double dash, Z21 double dash, Z22 डबल डैश. तो हम जब डबल डैश ले रहे हैं तब इसी नेटवर्क के दो पार्ट्स बनाएंगे, मतलब सेम वैल्यू 3113 and 3113, and answer therefore will be 6226. So this will be your final answer. So when they say identical section, life becomes a little easier because you don't have to identify two networks like we were doing previously in all the questions. We don't have to identify any separate network. We will go ahead and we will try to take the same network and just put the values twice. So that would be your series connection. So in a series connection, we are using nothing but your Z parameters, and we're just adding it up. And you don't have series parallel connection. आपको सिर्फ सीरीज कनेक्शन है, पैरेलल कनेक्शन है, कैस्केड कनेक्शन है. So do you have any doubt in this? Anyone? Any kind of doubt? We can take the doubts right now. Can you answer, class? What method is being used in Z parameters? KVL. Very good, Atharva, Pragati. So we use KVL in Z parameters. What about Y parameters? What about Y parameters? KCL. Very good. What about, yes, Advait, Pragati, and Atharva. Now tell me, what about hybrid parameters? Hybrid parameters. Yes, mesh only, that is KVL only we are using. Now when I say series connection, then which parameter is being used? When I say series connection, which parameter is being used? Z. Very good, Advait. Y, Ritesh, Mihir. When I say ABCD parameters, what kind of connection is being used? When I say ABCD parameters, what kind of connection is being used? Cascade. Very good. Cascade में हम क्या करते हैं? Cascade में ladder is also correct. Cascade में हम क्या करते हैं? Siddesh, very good. Spencer, yes. Cascade में हम करते क्या है? Are we adding? Are we dividing? Are we subtracting? What are we doing? Cascade में हम क्या करते हैं? Yes, we multiply. Very good, Pragati, Ritesh, Atharva. We multiply in cascade two matrices which are in ABCD. When it is Z parameters, it's a series kind of network. We are adding them. When it is parallel, then it is nothing but we are going to add them up again. Now, what the kind of questions that can come in the multiple choice is that the kind of network you have to identify. So if I tell you that the output of one network is connected to the input of the other network, what kind of network are we speaking about here? If I say the output of one network is connected to the input of the other network, then I'm talking about cascade connection. So you have to identify those networks. That kind of questions can be asked. We have two ports. If both the ports are connected, the network 1 के दोनों ports, network 2 के दोनों ports से अगर connected है, then what kind of network are we talking about? Then it is parallel. Very good, Pragati. And if you are talking about one port of one network connected to the other, then we are talking about series. You get the whole thing about it. I mean, the understanding should be correct, because when we go for multiple choice question, they are checking your understanding. They're not exactly checking your writing skills, right? So they want to know whether you've understood the concept. So I hope there is no doubt in interconnection of two port network. And normally, as I said, when we go to select a network, it is not that we can't take any other kind of network, but T network and pi network are standard ways to identify the interconnection of two networks. So that will really help you in understanding or in dividing the network effectively. Suppose they might solve one network for you, tell you to solve the other network and get the resultant answer. So these kind of questions can be expected from this part. So there is no theoretical derivation part from this chapter, but you should be able to identify reciprocity, symmetricity, interconnection, z y abcd, and this part should be solved. As well as, because they're going for a bigger paper, they're planning something which is going to be subjective and objective. So there will be parts where you will have to solve and show, right? So we are looking forward to a paper which is going to be subjective as well as objective, right? So let's see that I hope all of you are sitting at home and studying, preparing for the examination, because that is very important. We may have the exams offline. So that means you should be prepared for the examinations that are coming ahead of you, right? So please start solving these questions. Now, the one very small part what is left in this chapter is the transition. That means if I give you Z parameters, you remember I gave you a table of formulas. So if I know the Z parameters, from that I can find Y, I can find ABCD. So that's going to be a little by heart that you have to do. You have to know the formulas. So I just want all of you to revise the formulas. Obviously, I will introduce the formulas to you, but you will have to revise the formulas, because there are a lot of set of formulas. Matlab Z in terms of Y, Z in terms of ABCD, Z in terms of hybrid, then Y in terms of Z, Y in terms of ABCD, Y in terms of hybrid, then ABCD in terms of Z, ABCD in terms of Y. So there is going to be a lot of formulas in that particular part where you will have to learn it by heart. So that will bring us end of this chapter. And then what is left is only a small part of transient. So let's take a break today, and I will take a lecture tomorrow. Is it okay with all of you that I can take a lecture at the same time, 10 o'clock? Is it okay if I can just, in the coming this week, if I can finish off what I have to finish? Okay. So based on this, I will send you a small assignment on two-port network. So I hope that you will be able to upload it at the end of tomorrow's session. So at the end of tomorrow's session, I will give you a Google form to fill it. Please submit that particular assignment. It will be both subjective and objective. Okay. So thank you very much.
Thank you, ma'am.
Thank you. Thank you, Ataru.